Hi everyone, in this video we are going to practice doing a dimensional analysis for actual chemistry problems. So if you haven't watched the previous video where we just practiced straight dimensional analysis, so in other words our math skills, I would highly recommend that you start with that one and then come to this one. Otherwise, if you're ready, we're going to dive straight into the chemistry dimensional analysis, which really could just be called unit conversion, alright? So let's start off with something very, very simple, strictly speaking, that we're going to look at our chemistry part. So how many millimeters are in 0.85 meters? Go. All right, did you get an answer? Hopefully you did. There really was only one number that you could start with, which is the 0.85 meters. And what we're doing is trying to convert that to millimeters. So meters is on the top here. Meters needs to be on the bottom. Meter is our standard unit. That's our base unit. And so we can just do 1 meter and convert directly to millimeters, which is awesome. And then hopefully you now know, or else you're able to look up in a chart and see that anytime we have the word milli, that usually is indicating that we have 1,000 of whatever species it is that we're talking about relative to the standard unit. So there's 1,000 millimeters in every 1 meter. So all you have to do is see that your meters cancel out, multiply 0.85 times 1,000, and you end up with 850 millimeters in 0.85 meters, which makes sense, right? Hopefully that makes sense. Always check your answer and say, okay, if I have a small amount of meters, I probably have a lot of millimeters. If you came up with a teeny tiny amount of millimeters smaller than your meters, that doesn't really make sense. That's not logical. So always check your answer and make sure that you didn't do something silly and just flip the unit just because you're not thinking straight for whatever reason. All right, let's try another one. How many kilograms are in 772.8 grams? Go. All right, did you get an answer? This one is the same as the last one. You start with what you know and then try to convert it to your desired unit. So we have 772.8 grams. We're trying to take grams to kilograms. So if we have grams on the top here, we need to put grams on the bottom. Luckily, grams, again, just like with meters, that's kind of our base unit. And so we can convert that directly to our other unit, which would be our kilogram component. So we know in every 1 kilogram, there are 1,000 grams. Just like with milli, you should also know killa. Milli and killa are two very, 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 very common ones. They're probably the most common ones that we use. Those two you need to have in your back pocket. You need to know that kilo's big, milli's small. You just need to know those, okay? All right, so now our grams cancel out. We're left with kilograms. 772.8 divided by 1,000 gives us a value of 0.7728 kilograms. Check it. Does that make sense? If we have 772 grams, would it make sense that we have a small amount of kilograms? Absolutely, right? Kilograms is a bigger unit than grams. It absolutely makes sense. This is logical. Always check your answer, okay? Let's try another one. A little bit harder, maybe, just because we're not going from a base unit. We have 2 little fancy units here. So now see if you can do this. How many kilograms are in 2.525 milligrams? Go. All right, did you get an answer? This was definitely trickier. If you stumbled on this or got caught up, do not freak out. That's totally normal, but let's work through this together so that you can do this again in the future. All right, so you start with what you know. 2.525 milligrams. We are in milligrams, so the bottom unit has to be milligrams. Now, fancy people out there, you could go directly from milli to killa. I never do that personally, and I have a PhD. I feel like that's a very, very easy way to make a mistake, so even I don't do it, but if you are better than me and you can do this very, very easily, then I would highly encourage you to do that. But for me personally, it doesn't work. All right, so milligrams is on the bottom. I'm going to take milli to gram because gram is our standard unit. So we know that for every 1 gram, there are 1,000 milligrams, right? Grams is a bigger unit than milligrams. So right away, we get our unit out of milligrams and we're left with grams. Grams is not where we're trying to go there. We're trying to go to kilograms. So we need to take our gram unit and convert it to kilogram. So just like before, this is something you need to know. For every 1 kilogram, you absolutely are always going to have 1,000 grams, okay? So now, grams cancel out, you're left with kilograms. 2.525 divided by 1,000 divided by 1,000 is equal to 2.525 times 10 to the negative 6 kilograms. Does that make sense? We have a tiny quantity of a teeny tiny unit. Does it make sense that we have a really small of kilograms? Absolutely. It makes the most sense to report this number in milligrams. We do not want to report this in kilograms. There's that huge weird number. We wouldn't do that. That doesn't make sense. So this number, this calculation absolutely is perfect. Mwah, gorgeous. All right, let's try one more. finish on a strong note. This is an odd one. We don't usually use centi, but you will see it sometimes, so I do want you to be familiar with it. So I'm trying to get you to go from 178.2 kiloliters to centiliters. Go. All right, did you do it? Tell me you did. I hope you did. I really, fingers crossed that everyone gets this one perfectly right. I hope you really did. So what you do is you start with what you know. So 178.2 kiloliters. You're in kiloliters, so your bottom unit needs to be kiloliters. Like I said before, I always go back to the standard unit and then recalculate to get into our new fancier unit. So kiloliters. We know that for every 1 kiloliter, there are 1,000 liters. Same thing. We have 1 kilogram, there's 1,000 grams. That kilo is what's telling you 1,000. All right, so now kiloliters cancels out, kiloliters cancels out. Now you're in liters. Liters is in the top, liter needs to be in the bottom. We're trying to go to centiliters, so that's what's going to go on the top now. All right, so now this is the fancy part. For 1 liter, we have 100 centiliters. Century, think century, that's 100. That's how I personally remember it. That cent should tell you 100. So now our liters have canceled out. We're left in centiliters, so now we do 178.2 times 1,000 times 100, and if you did this properly, you would end up with a correct answer of 1.782 times 10 to the 7 centiliters. Whew, that's a big one. All right, hopefully you were able to do that. If you can do this, you're going to be ready when we really throw the chemistry on hard and we actually convert from dimensional analysis to stoichiometry, but that's coming later on in the semester. If you do not have this down, by the time we get to that section, it's going to be too late. So please promise me that you're going to master this now, work on it now, get it down, and then when we get to the end, you're going to do absolutely fantastic. A's for everyone. Have a great week, guys. Take care of yourself and drink so much water.